They're kind of the unseen architects of our super complex world, the real masterminds behind our most ambitious tech. So in this explainer, we're going to dive deep into the life of one of the most critical roles in modern engineering, the systems engineer.
So, think about this for a second. What's the common thread between a whole fleet of self-driving cars, a fully automated smart factory, and maybe even a mission to Mars? Well, the answer isn't a single piece of tech. It's a single, absolutely vital role that makes sure all those countless pieces fit together perfectly. The best way to think of them is like the conductor of a technical orchestra. You've got hundreds, maybe thousands of specialists, software devs, hardware engineers, data scientists, all playing their own complex part. The systems engineer, they're the one holding the master sheet music, making sure every single component, every line of code works in perfect harmony.
Okay, so how on earth do they do it? Well, their first mission is always the same: taming complexity. It's all about taking a huge, sometimes really vague idea and hammering it into a concrete blueprint that can actually succeed. And listen, every big project starts right here, in what feels like total chaos. You've got these tangled technical requirements, competing needs from different teams, budget problems, all pulling in different directions. If you get this stage wrong, the whole project is at risk of just catastrophic failure.
So, to create order from that chaos, they follow this really methodical process. First up, analysis. They break the giant problem down into smaller, solvable pieces. Then comes the design. They create the actual blueprint. And finally, integration. They map out exactly how this new thing is going to plug into everything that already exists.
And this, right here, shows why the role is so unique. Success isn't just about being a technical wizard. It demands this powerful blend of hard skills, like risk management, and these crucial soft skills, like big picture thinking. See, you can't just know the tech. You have to be a master collaborator to really conduct that orchestra.
Which actually brings us right to their second mission. And this one is maybe the most human of them all: bridging the gaps.
Here's a scenario that happens all the time. The software team, they want to move fast, right? Push out new features. But the hardware team, they need to guarantee stability. And they're stuck with the limits of physical parts. They have totally different goals, different priorities, and honestly, they often speak completely different technical languages.
So, the systems engineer steps right into the middle and becomes, for all intents and purposes, the universal translator. They're the communication hub. They make sure the software team gets the hardware limits while the hardware team understands the goals for new features. Their whole job is to get everyone aligned and marching toward the exact same finish line.
But look, a perfect plan is completely useless if it doesn't survive contact with the real world. And that brings us to Mission 3, the reality check.
This is the system validation process, and it's where theory smacks right into reality. They meticulously plan out test scenarios. They integrate every single component, and then they test relentlessly. The goal is simple: find every single problem before a customer does, and then make sure that system stays healthy for its entire life.
And sometimes reality hits hard. As one engineer on Reddit perfectly put it, the day often starts with putting out some totally unexpected fire. This reactive, high-pressure problem-solving, it is a massive part of the job.
So what that means is a typical day is this super dynamic mix. A big chunk is for that planned, deep thinking work, the design and analysis. Another huge piece is spent collaborating. But then there's that crucial slice left for reactive troubleshooting, putting out those fires that always inevitably flare up.
And the potential for those fires is just immense. Why? Because we're often talking about managing the interactions between thousands of components, data sources, and lines of code. The scale of this complexity is absolutely staggering, and it's their job to master it.
But what happens when we zoom out from all these daily missions? What you start to see is that this role isn't just about managing today's technology, it's about architecting the technology of tomorrow.
So yeah, let's fast forward a bit. The life of a systems engineer is evolving at this incredible pace. And if you look at industry projections, the tools they're going to be using soon are pretty much straight out of science fiction. I mean, just imagine using AI to run millions of virtual tests before a single piece of hardware even gets built, or leveraging quantum computing to solve problems that are basically impossible today. Using VR and AR to design systems that are perfectly intuitive for us humans. This isn't just speculation. This is the future of this role. So what's the ultimate takeaway here? A systems engineer isn't just managing complexity. They are actively designing the scaffolding of our future.
The real question isn't just what they do in a day, but what kind of world are they building for all of our tomorrows.